All right, MCT4C, day 55. This is the first of 3 or 4 days in a row that we're going to be solving polynomial equations. And that's the name of the unit, and that's the name of the next few lessons are pretty important. What's good is quite a lot of its review, including this 3-minute review question is a great question from last day's homework. I never assigned it. I saved it for today, but hopefully you tried it. And it involves polynomial expressions, right? And in fact, the way it describes it, it's actually a polynomial equation. And let's get at it. So for A, write an expression to represent the length of the new rectangular platform. Well, the new rectangular platform, well, what was the old one? The old one was 3 by 2, right? 3 feet by 2 feet. And then the new one has an area, it's been added the same amount on each side, right? We don't know how much that is, but it used to be 3, but we're going to add the same amount. Well, let's call that amount x maybe, eh? So that's going to be x plus 3, and this is going to be x plus 2. So write an expression to represent the length of the new rectangular platform. The length is just going to be x plus 3, isn't it? For B, write an expression to represent the width at x plus 2. Use an algebraic solution to determine the dimensions of the new rectangular platform. Well, hang on, the dimensions. Well, what do we know about it? We know that the area is double the area of the original platform. So the area of the new platform is twice the area of the old platform, right? Well, the area of the old platform was just 6 units, right? This area is 3 times 2, 6 units. So the new one is going to be 12 units. But what's an expression for the area of the new one? Well, it's just length times width, right? Length times width. And length is x plus 3. Width is x plus 2. And then we've got to solve this. And they ask for an algebraic solution. So what does that mean for us to do? Well, we've got a parabola here, right? 2 roots, and it's when is this parabola equal to 12 is the way to think of it on a graph. But they want us to use algebra. Well, what does that mean? That means I'm going to expand this, right? This is what we were up to yesterday. Right, there's 3, and there's 2 to make 5. Now, how do I actually solve this, remember? Well, you have to have one side equal to 0. So what I'm going to do is I'm going to subtract 12 from both sides, and I end up with x squared plus 5x minus 6 equals 0, right? How do I solve that? I don't remember how to do that. Well, now we can solve this by factoring this new expression. So why didn't you just it was factored over here, why didn't you just use this factored version? Because this side has to be 0 for a reason I'll remind you of in just a second. So here we need numbers that multiply to get -6 and add to get 5. And what is it? It's 6 and minus 1, isn't it? 6 and minus 1. Okay, and notice, how do we actually use that to solve the equation? Well, think about it. We got 2 things, and let me just get my 2 things here. I got 2 things, one here and one here, and they're multiplied, and the answer is 0, right? So I got 2 things. I'm just going to get my other thing here. Fill that with red, say. Oh, actually, let's use that second one that's actually filled with red. So I got 2 things. And when I multiply them, the answer is 0, right? Something times something equals 0. Well, what does that mean? It means one of these things has to be 0. either this is 0 or this is 0, or maybe both, right? So getting rid of my shapes, what do I know? I know x plus 6 equals 0, or x minus 1 equals 0. And there are the roots of this other parabola, minus 6 and positive 1. So this one doesn't really make sense for x to be negative, because I'd end up with a negative side of that triangle, so this one doesn't make sense. Doesn't make sense. And so therefore, x equals 1. What are the dimensions then? Well, the length is 1 plus 3, which is equal to 4. The width is 1 plus 2, which is equal to 3. And notice, if this is 4 by 3, that makes an area of 12, which is twice as much. So it's all good. The new platform is 4 meters or 4 feet? 4 feet. 4 feet by 3 feet. I think that's what it was. Yep. Is there another method that you can use to solve this problem? Explain. Would your method work if the original dimensions of the rectangular platform were something else? Well, what could we do? Well, we need to think about ways to solve either that equation or that equation. Well, we could use a graph, right? We could use a graph. This parabola goes through, whoops, -2 and -3, opens up, starts high, ends high. And where is this thing equal to 12? Well, there and there. Well, could we read it exactly that the answer was 1 and -6? Well, maybe not, but we might be able to use a TI-83 then to do that. Some people might have just been able to solve this. This is part D now. So I could use a graph. I could use a TI-83. I could use guess and check. Like, you know, I know that the parabola is, or the new platform has gotten bigger. I could just guess and check values to see if it's going to work out to 12. I mean, that's possible. I could make some sort of table and guess and check. There's lots of different ways to solve this problem, but what we're working on this whole chapter, and if some of these steps were fuzzy, that's okay, because that's what we're working on the next few days. Maybe I'll pause there for part 1. This is the part 1 is just the 3-minute review, I guess. It ended up being an 8-minute review, but the second part of the video will be really short. I almost promise.